Okay, 16.5. Let's look at 16.5, behavior of sequences. Now, can I have attention? Can? Another way of describing an increasing sequence, I repeat, another way of describing an increasing sequence is this. Make sense? Makes perfect sense. That means the next term is larger than the previous term. That means U2 larger than U1, U3 larger than U2, U4 larger than U3, therefore is increasing. So whether you say it's increasing or you say this, they actually mean the same thing. Of course, the reverse is true, is decreasing. You can say that the next term is smaller than UN plus 1 is smaller than U1. What about this kind of sequence, alternating plus 1, minus 1, 1, minus 1? It's very confusing, yes, but it's actually at some point it is increasing, at some point it's decreasing. So you can say that if your UN is positive, that means you can see, sorry, this is positive, look at 1 is positive, U1 is positive, we can say that the next term will be smaller than the U1. So U2 smaller U1 because U2 is smaller U1. But if UN is negative like this, then UN plus 1 is larger than U1. Just for completeness, we are discussing example 9. We typically don't look at this kind of series. Okay, just for completeness. We typically look at only the increasing or the decreasing type. Okay? Now, the one in the box is one that we want to look at. Okay, just in summary. Yeah? Okay. Very often in questions will ask you to show that a sequence is increasing or decreasing. Okay? So there are two methods here. One is algebraic method, one is graphical method. Okay, one is algebraic method, one is graphical method. Either way, we are actually making use of this idea whether, sorry, can I have attention here? Remember here. Let's look at example 7 again. If it's increasing, we say that UN plus 1 is larger than UN. We usually will write this. This is equivalent, right? These two are equivalent. We usually write this, and it's easier to show that something is positive. That means an expression is positive, rather than this form. So what is a number is larger than another number. You follow what I'm saying? Similarly, it's easier to show this. Okay, later on in the actual example, we'll find out how. Okay? Never mind. Let's look at example 10. Example 10, we have this recurrence relation. We have the first term equals to 2. Find the exact values of U2, U3, U4. Now this one, I don't intend to spend a lot of time. All you need to do is to use your hand, use your brain to calculate. Quite easy. Okay? Right? But take note, the question asks for exact. So we only use the GC to check answer. Cannot tell me by GC U2 equals to 7 over 2, U3 equals to 43 over 11, U4 is 259 over 65. You have to use this step. These steps are critical. Okay? You have to show that you understand what it means to find each term using the previous term. Can? We only use the GC to check answer. Okay. Part 2. Part 2 asks us, given that the sequence converges, show that UN tend to 4. Now this one we are quite familiar. Alright, we are quite familiar. How do we find the limit of the sequence? This time you let as n tends to infinity, un tends to alpha, un plus 1 tend to alpha. You are supposed to show that alpha equals to 4. But you do it the same way. Whether you are given the value of alpha, never mind, just do it the same way. As n tends to infinity, un tends to alpha, un plus 1 tend to alpha. Substitute in the recurrence relation equals to 5 alpha plus 4 over alpha plus 2. By now, you should be quite familiar with this step. Correct? By now, this step should come very natural to you to find alpha. If there is nothing that you remember from today's lecture, can you please remember how to do this? This will at least give you 2 marks. Can? Okay? Can you please remember how to do this? Okay? Okay, you are fast, you can do this on your own. I'm just going to do this quickly. And then you get alpha squared minus 3 alpha minus 4 equals to 0. Again, you have 2 possible solutions. Alpha equals to -4 or alpha equals to -1. Oh, sorry, 4. Sorry. Now, we can therefore see actually from the recurrence relation here, there are no negative signs again. Correct? No negative sign, and then U1 is a positive number. So therefore, all the terms are positive. So therefore, alpha equals to 4. Shown, done. It's part 3 that we are interested to discuss here. Given that un smaller than 4, show that un smaller than un minus 1. Un plus 1, sorry. Okay. I repeat one more time. To show this, it's a lot easier to show this. Okay? It's a lot easier to show, consider un minus un plus 1 to show that this is eventually negative. To show it is negative. That's our objective. If I can show that un minus un plus 1 is negative, our job is done. Follow? How do we do so? What is un plus 1? Un plus 1 expression is given. Correct? Un plus 1 is in terms of un. So we copy and paste. So far so good. This is a very standard step. Consider un minus un plus 1. If we can eventually come here and show that this expression is negative, our job is done. Correct? Make sense? And how do we get started? We replace the un plus 1 with the expression in terms of un. That means replace with the recurrence relation. Then you see, how are we going to do this? Never mind. It's one step at a time. What? Anybody? Guess? What do we do? Come on. Just do something lah. Cannot don't do anything lah. Must do something lah. How? Hey, let's do something immediately. What are we going to do? S33. Where are you? Don't. Okay, somebody minus 33. Come on. Mathematics. Where? Yes. Very good. Express the single fraction. Excellent. Oh, yeah. What a lousy straight line. Okay, never mind. You know what I mean. So, we express this as un square plus 2un minus 5un plus 4 over. Very good. Excellent. Thank you very much. Then what do we get? We get a quadratic expression in the numerator, un square minus 3un minus 4 over un plus 2. Do we find the numerator familiar? Do we find the numerator familiar? The numerator? Yes, we should find the numerator familiar because just now when we solve for alpha, we actually have the same numerator, which means we can factorize. Okay, I'm going to use an idea when we solve inequality. Remember, we want to show that this thing is negative. Now, if I can show that this is negative, if I can, whoa. Okay, I say again. If I can show that this is negative, this is positive, I'm done. Because no matter what, negative times positive will always give you negative. Alternatively, if I say that it is negative, will also give us negative. So, because I have factorized this expression, I then consider the signs of the individual factor. I say again, I consider the signs of the individual factors. So let's consider each factor. Let's look at un minus 4. Is this positive or negative? Don't know. Never mind. Look at the question. Question on page 51, part 3. You are given that un smaller than 4. So is un minus 4 positive or negative? Negative, correct? Yes, because you are given that un smaller than 4, therefore un minus 4 is negative. So I'm going to just write here negative, okay? Later, I will show you how to present. Later. But let's, for discussion's sake, let's do it like that first. What about un plus 1? Obvious positive, right? Because un already positive. All the terms are positive. So whether you plus 1 or plus 2, it will be positive. Now comes the magic part. I have one factor that is negative, two factors positive. No matter what is it, the whole fraction will be negative. So the idea is actually consider each factor. So the presentation part goes like this, right? Presentation part goes like this. First, this first part, we know this, therefore this is negative. I'm considering the first factor here. Okay? Then the second and third factor are here because we know that un is positive for all n. Whether you plus 1 or plus 2, it will always be positive. Therefore, we can conclude that this whole fraction is negative, and therefore un minus un plus 1 is negative. And of course, I can bring this across. I can safely make this conclusion. I guess I was a bit ambitious when I said I wanted to complete this chapter. Never mind, it's always to be ambitious, right? Aim higher. Okay? Never mind. Part 4. Okay, I can complete part 4. What did part 4 say? Part 4 says that given that un smaller than 4, you want to show that un plus 1 smaller than 4. Okay? How do we do it? Now, you want to show un plus 1 smaller than 4, we don't know how to start. At least we can replace the un plus 1 with an expression in terms of un. That's the minimum we can do. If I can show this is smaller than 4, then this must be smaller than 4. Follow so far? Okay, how do we do it? Now, un plus 1 is equals to, of course I copy and paste only, this one. I'm trying to make use of the fact that this is smaller than 4, this is smaller than 4. How do I show that everything is smaller than 4? Complicated, right? And then the un in the numerator and denominator getting in the way, right? So if I can, in inverted commas, I get rid of the un either in the numerator or in the denominator, then it's a little bit easier. So I do long division to get this term. Okay, I'm going to jump a few steps. Okay, just one step, a long division only. So from here to here is just long division. Okay? Can? Let's assume we know how to do it. Okay, which we should. Can? Now we have a slightly easier job. Because now un, which we know is smaller than 4, is only appears one time. Okay, now we can attack from here. Attack here. Okay, we know un is smaller than 4, therefore un plus 2 must be smaller than 6. Just add 2 on both sides. Too easy. Okay. Now, then what about 6 divided by un plus 2? Can I divide un plus 2 on both sides? Can or cannot? Cannot. Why cannot? You don't know whether positive or negative, but I know it's positive. Un is positive, right? So can Can. Because, let's take note, because I know un plus 2 is positive. If you're not sure, cannot. I divide both sides at UN plus 2 because I know for sure that UN plus 2 is positive. I think we are almost there. We start off here, we end up here, we want to end up with 5 minus this. But before that, I want a minus to appear, right? So I multiply both sides by -1. Negative, sorry. Negative. -1, -6 over UN plus 2. I multiply left hand side, right hand side with -1. Should I switch the inequality sign? Yes, we should. Then after that, I add 5 on both sides because I want to end up here. Oops. Because I want to end up here. Okay, let me finish off. Then, beautiful, isn't it? We end up with this. Correct? This is smaller than 4. Therefore, UN plus 1 is smaller than 4. Correct? Good? Okay, we are only left with the graphical method, which is quite fast. I think we only take about 10 minutes. Okay? Okay, thanks.